Write the expression for the reaction quotient, QC for the given reversible gaseous reaction. PCl3 plus Cl2 is in equilibrium with PCl5. The reaction quotient is written as QC equals PCl5 over PCl3. Cl2. Calculate the initial molar concentrations. The volume of the rigid reaction vessel is 1.00 liters. Using the molarity formula, M equals moles/volume. PCl3 is equal to 1.5 moles over 1.00 liters equals 1.5 molar. Cl2 is equal to 1.0 moles over 1.00 liters equals 1.0 molar. PCl5 is equal to 2.5 moles over 1.00 liters equals 2.5 molar. Calculate the value of QC. Substitute these initial concentrations into your reaction quotient expression. QC equals 2.5 over 1.5. 1.0 equals 2.5 over 1.5 approximately 1.7. Compare QC to the equilibrium constant. Kc, the equilibrium constant for the reaction at this temperature, is Kc equals 6.5. Comparing the calculated QC to Kc, 1.7 less than 6.5, therefore Q less than Kc. Because Q less than Kc, the system is not yet at equilibrium. To establish equilibrium, the reaction must shift to the right, the forward direction, to consume reactants and produce more products, which increases the value of QC until it equals Kc. Analyze the effect of the forward shift on gas moles. Examine the stoichiometric coefficients of the gaseous species. Reactants. 1 moles PCl3 plus 1 mole Cl2 is equal to 2 moles of gas products. 1 moles PCl5. As the reaction shifts forward, every cycle of the reaction consumes 2 moles of gas to produce only 1 mole of gas. Consequently, the total number of moles of gas, N, in the vessel decreases. Relate the change in gas moles to the measured pressure. According to the ideal gas law, PV equals nRT, pressure is directly proportional to the number of moles of gas when volume and temperature are constant. P equals RT over V. And since the container is rigid, constant V, and the temperature, T, is constant, the decrease in the total moles of gas, N, must cause the measured pressure inside the vessel to decrease, making option C the correct answer. The correct answer is option C. The pressure will decrease because Q less than Kc.